Hi, welcome to the JAL Bathroom Timer project. In this video I'm going to explain how this timer works, and I'm using, as you already see, the JAL programming language. And if you want to know more about this project, you can also find it on Instructables, and I will put the link in the description. So what will be the contents of this video? First, I will explain the project and why I built it. Then I will show the schematic diagram of this bathroom timer, a picture of the hardware as I build it. Then I will explain the program in some main steps, but later I will also give a more detailed explanation of how the software works. And there will be a demonstration video of the bathroom timer in action. So, what about this project? I just needed a simple 3-minute timer in my bathroom. And this bathroom timer is programmed with the JAL programming language, and it's using a PIC microcontroller. And this is a very simple project, so that's why I also want to use this project to explain it in more detail, so that you know what you need to do when you want to get it running on a PIC microcontroller. And if you want to know more about JAL, you can visit the JAL website. I will put the link also in the description. So, the schematic diagram is very simple. It consists of one microcontroller, a LED, a push button and 2 batteries, and that's all. And this is how I built it. I used a small plastic cabinet for the push button and the LED, and as you can see, it fits nicely with the microcontroller and the 2 batteries. So if you look at the main program, what are the steps? First, you have to include the correct device file for the microcontroller. As you may know, there are a lot of different PIC microcontrollers, each with their own registers and so with their own device file. Then you need to define the clock frequency that is used by the PIC microcontroller, because the compiler needs it in order to calculate the correct delay. Then you need to configure the PIC microcontroller and its I/O pins. Then some constants are defined that are used in the program to make it easier to maintain. Then it will bring the LEDs and it will create the timer, of course. And in the end it will put the PIC into standby mode, because it's battery powered and you want to save the lifetime of extend the lifetime of the battery. And in standby mode the PIC hardly uses any current. So let's look at the program in more detail, and we do this via a live demo. So this is the JAL program. It starts by including the correct device file. As I mentioned before, there are a lot of PIC microcontrollers, so you need for each PIC microcontroller a different device file. Then you need to tell to the compiler which target clock is used, because it needs that for the delay it will calculate. And here are some settings for this, specific for this PIC, which are also called fuses. And in this way you can configure the behavior of the PIC microcontroller. So for example, I'm saying that I'm using the internal oscillator, but I don't want the clock to be on one of the output pins. This PIC has a watchdog timer, which I will not use. It has a brownout reset feature, which I will not use. And the reset input, the memory clear, is set to external instead of internal, because I needed to reset the microcontroller. I noticed when I made this timer that the internal oscillator was not exactly at the right frequency, but with the oscill register you can tune the oscillator frequency. Then after reset, all the pins of the PIC microcontroller are analog, and with this function you can make them digital. Then I will wait some time for the hardware to stabilize, which is in fact not really needed for this PIC microcontroller, but in some cases the more complex PICs, which has a lot of hardware on board, it might be handy to use a delay. This is just to be sure. Then the pin definitions. I have one LED which is connected to pin GP2, which is pin 5, but I'm using an alias. That makes it easier if I want to change pins, that I only need to define it here and I can use the term LED in my program. And of course you have to set the direction of this pin to output. When you reset a PIC microcontroller, all the inputs are floating, and that's not what you want. But luckily the PIC has a weak pull-up resistors on board which you can enable. And I do this by this instruction, so I enable all the pins except GP2, which is output, and GP3, which is the reset input, and that has no weak pull-up resistor. But it's pulled up externally by a resistor. Then I'm defining some constants, for example the blink time, but this is expressed in microseconds because I'm using the microsecond delay function of the compiler. So this means 1 second, the blink will be 1 second, LED will be 1 second on and 1 second off. The delay time is 3 minutes or 180 seconds. When you reset the PIC, it starts with 2 blinks, and after the timer has passed it will show 10 blinks and then it stops. And for switching on and off the LED I'm using some constants. And here's where the main program starts, which is very short of course. It starts by switching the LED off and then it starts blinking. This constant was 2, so it will blink twice. It will put the LED on, it will wait the blink time, which was 1 second. It will switch the LED off and again it will wait the blink time. After the repetitions it goes here and it waits for 3 minutes, which was this big number. Then it will repeat the same thing, only with 10 blinks instead of 2, and when all is done the PIC microcontroller is put into standby mode by this assembly instruction sleep, and then it will consume very little power. If you compile the program you will see it only uses 217 bytes of the 1K which is available, and it uses 6 data bytes of the 64. So there's enough space left to extend this program if you want. In the following video I will show this timer in action. It starts by pressing the reset button and then it will blink twice at the beginning, and after 3 minutes it will blink 10 times, and then it goes to sleep, but that's of course you can't see of course. I hope you liked this video. See you next time and thanks for watching.